In this lecture video, let's take a look at application of quadratic functions. So we already talked a little bit about how to find the vertex, okay, how the parabola opens up, opens down in the previous lecture video. So I want to use this particular video to talk about some of the application problems. So let's say among all pairs of number with a sum of 100, okay, so just like 1 plus 99 is 100, okay, or 2 plus 98 is 100. Find the pair, find the two number whose product is going to be the maximum. So the idea here is to think, okay, something plus something is going to be 100. So one of the two number got to be x. So if I say the first number is x, then what should be the other number? Okay, and you cannot say, well, let the other number to be y, because the other the variable y in these type of problem is going to be the maximum product. Okay, the variable y actually representing the maximum product in this particular example. Okay, so your variable y representing something else. So here I cannot using the variable y to say the other number is y. So I can only use one variable. So I will need to get this question mark by itself. To get this question mark by itself, all I got to do is move my x to the other side. Then the other number is just going to be 100 minus x. So I got one number that is x. The other number is going to be 100 minus x. Okay. So these two numbers is going to produce a maximum product. So my function is going to be maximum product, which means I will need to multiply these two numbers together so I can find what each number is here in a minute. So my maximum product equal is almost like saying y equal. So the y representing the maximum product. So if I do a quick distribution, I'm going to move my x times negative x up front to be negative x squared plus 100x. Okay, so my maximum product function turned out to be a quadratic function. All right, by the leading coefficient being negative, I know my parabola will open down. Okay, so the maximum product got to occur at the vertex. Remember now, the vertex is also called the absolute maximum or absolute minimum, depends on whether it's open up, open down. So at the vertex, okay, the vertex will create the maximum product. The y value representing the maximum product here. So the x value is actually going to be one of my two numbers that are already determined. Okay, so the question asks, among all pairs numbers with a sum of 100, find the two number whose product is maximum. Okay, so in order to figure out that number, okay, I basically set up my function as a maximum product function. Okay, so wherever the maximum product is going to occur, which is got to occur at the vertex, then that x value is one of my two pairs. All right, so needless to say, this problem is basically asking you to find the vertex, okay, the h and the k. So my x value, which is going to be my h, is, all right, this is in the a squared plus bx plus c form. So I'm going to use my vertex formula, negative b over 2a. So that will give me negative b is 100 over 2 times my a, which is 2 times negative 1. So negative 100 over negative 2 is going to give me 50. All right. So this problem is not asking me to find what the maximum product is. So once I got my x, then one number is going to be 50. The other number is 100 minus x, which is also another 50. So the pair number with the sum of 100 that will create the maximum product, the two numbers are 50 and 50. All right. Let's try another one. The back of Johnny's property is a river. He would like to enclose a rectangular area. So let's draw a picture real quick here on the side. So let's say here is a river. He would like to enclose a rectangular area. He will use the river as one side of the fencing for the other three sides to create a coral. So that means his fencing will only cover the other three sides. Okay, one side is covered by the river. He does not need to put fence on the river side. There is 880 feet of fencing available. What is a dimension that will create the maximum area? Okay, so when we talk about a rectangle, we're always going to have a length and the width. Okay, so again, just like the previous problem, my variable y will representing the maximum area. So I can only use one variable here. So the question is, who do I want it to be x? Do I want x to be the length, or do I want the x to be the width? Okay. The answer to that is either or. You can pick either one, but let the x representing the width will actually be easier because it will actually cover two of the three sides. Okay. It can actually cover two of the three sides. So since I have 880 feet of fencing that is for all three sides, the other two sides are x already. So that will be 880 total minus the one width and minus another width. So that will be minus 2x. So my length in terms of an x will be 880 minus 2x. Okay. So if I set the width to be x. Let me write it down here. 880 minus 2x. All right. So the maximum area, which is my variable y, is going to equal to, okay, so they say the word area. Area is always length times width. So I will multiply my width and the length together. All right. If I multiply this out, and you will see x times negative 2x will create another quadratic function. All right. And again, this quadratic function by leading coefficient, since the leading coefficient is negative, this parabola got to open down. So the maximum area, the maximum y value got to occur at the vertex. So make sure you understand this. The y value representing at the vertex representing maximum area. All right. What does the x value represent? Well, we already set x to be the width. So the x value representing width. Okay. So in order to find a dimension that will create the maximum area, I need to find a dimension of my width. Okay. That will create the maximum area. Therefore, I can plug it back in to what my length set it equal to here up here to find the length. So again, using the vertex formula, my x value or my h is going to be negative b over 2a. So that will be negative 880 over 2 times a is negative 2. So this is basically saying negative 880 divided by negative 4, or you can say 880 divided by positive 4. So that will be 220. All right, since my h is the same as my x value, okay, then my width will now become 220 feet. Okay, so the dimension of the width, 220 feet, will create the maximum. So what is the length? The problem never asked me what is the maximum area. To find the maximum area, all I got to do after I find my length and width that creates a maximum area, all I got to do is just multiply them to actually find what's the maximum area. Or I can plug in the 220, okay, back into my function to find the k. Okay, but I don't need to find the k in this problem. So I'm going to just plug it back in here and say 880 minus 2 times 220. That'll give me 440. So my length that will create the maximum area is 440 feet. So these two are my dimension. So if I multiply these two, that will give me the maximum area. Or I can plug in 220 back into the function, like I showed you before, how to find K, okay, to find the maximum area. All right, draw a picture, it helps. The revenue function of a flower shop is given by this function called R of X. So R representing the word revenue. So whenever you are given a model, this is what we call a model, make sure you know what each variable represents. Okay, the R's of X representing the revenue. Okay, so the Y value of this function is the revenue. Dollars, where X is a number of units sold. So the variable X representing how many are sold. P of X, okay, is the unit price. So my unit price function is 200 minus 0.2x. Find the maximum revenue. So my revenue function is x times P of X. And since P of X is 200 minus 0.2x, so I will multiply. The reason why I'm multiplying because my revenue function says x times whatever P of X is. All right, so my maximum revenue, if I do another distribution, you will see this is negative 0.2x squared plus 200x. So this is my revenue function. So in order to find the maximum revenue, all I gotta do again is find the vertex. So understand this, the maximum occurs at the vertex. In this problem, the Y value represents the maximum revenue. So the X value will represent the maximum number of units need to be sold, okay, to create that maximum revenue, okay? So your X value, they already told me X is the number of units sold. All right, so when I find my H or my X value of the vertex, negative B over 2A, that will be negative 200 is B over 2 times negative 0.2. So this is basically 200 divided by 0.4. And I get 500. So this 500 representing a unit sold by being located on the vertex, it also tell me that the 500 units are the maximum number of units sold that will create the maximum revenue. So the problem never asked me how many units I have to sell to generate the maximum revenue. It only want me to find the maximum revenue. That means this problem I need to actually find the maximum revenue or the K or the Y value. So I'm going to simply plug it back into my function. Okay, so that would be negative 0.2 times 500 squared plus 200 times 500. Okay, let's see what is my maximum revenue. Negative 0.2 times 500 squared plus 200 times 500. All right, which is $50,000. All right, so the maximum revenue is $50,000. Then the unit got to be sold to generate that 50,000 got to be 500 units. Okay, so just a quick 3 example on how we can use the vertex formula. Okay, that actually using the vertex formula to help us find the maximum product or the maximum revenue. Okay, all right, that will conclude this video. Thank you for watching.